my presentation today, I'm going to be discussing river mangroves. So as Jody explained, at Fisheries, I protect coastal wetlands by assessing development proposals that could have impacts on them. And so I minimise those impacts with a range of different conditions imposed on the developer. So as I'm doing my job, I often wondered just how impacted are our coastal wetlands. Now, let's see. River mangroves are this low shrub here, just that forms a dense thicket along the foreshore of our estuaries. Now you can see them there as the hedge in front of the grey mangroves, which are the taller shrub behind, in fact, taller tree behind. There we go. So river mangroves were extensively harvested for a range of uses, particularly as sticks for oyster culture during 1900 to about 1950. Now this is only briefly mentioned in the literature, and in fact most wetland managers who I've spoken with don't really appreciate that this harvest happened, and they're certainly not across the scale of the harvest. So through a range of assessment of reports, so using a range of reports, I've constructed a timeline of key events that shaped the harvest of these river mangrove sticks. Now I've attempted to quantify the scale of the mangrove stick harvest from the Richmond River using shipping records. And then I'll conclude my talk by outlining how the biology of river mangroves supports the case that this extensive harvest has left a legacy on our coastal wetlands. And because of this, I'm suggesting that we may need to rethink the baseline. So, how were these river mangroves used? During spring and summer, free-swimming larvae from the Sydney rock oyster, they search for a place to settle and develop into an oyster spat. So suitable materials can be set out to maximise the settlement of this spat, and this material is known as culch. During the 1900s, 4 to 6 foot lengths of river mangrove sticks in bundles of 10 to 15 quickly became the preferred method of culch. About 6 months after a heavy spat fall, the oyster farmer would take those bundles, which you can see in the top slide, the bundles of mangrove sticks, and they'd move them into more brackish waters further upstream. So the individual sticks were then staked out, forming dense runs. About 2.5 years later, they were harvested. By this time, the bark of the river mangrove, river mangrove stick was rotting, and so hitting the side of the stick on the gunnel of your oyster punt would see the marketable oysters fall off into the punt, and then the stick was thrown away. So it was rather efficient sort of use. And so for the work I'm reporting on today, I've reviewed 65 different annual fisheries reports between 1883 and about 1960. The reports prior to 1921 were 70 plus pages or so, and they included region-specific updates. Later reports were generally less specific, only about 20 pages. I used Trove to access newspaper articles from last century using search terms oyster stick, mangrove stick, culch, and the term black mangrove. Now, I couldn't use the term river mangrove because that's not what was the name of black mangrove at that time. So anyway, I found 118 entries from about 36 different newspapers relating to the harvest of river mangroves for oyster culture. 39 of those 39 were about the harvest of river mangroves in the Richmond River, where I concentrate my work here, and 33 of those date from the 1930s. I also investigated historic parish maps, aerial photos, and undertook some field investigations. And I've used a 1 metre quadrat, we've got to go on to the next slide, a 1 metre square quadrat to estimate the number of potential river mangrove sticks growing in a square metre. Now there's a host of limitations to my study. I've only looked at coastal waterways in New South Wales, north of Sydney. And my source documents, they're generally from 1900 to about 1950. And both my main sources of information, the fisheries reports and the newspaper articles, they're incomplete records. They also suffer bias. So we're only ever going to come up with a partial reconstruction of this topic. I've also not yet undertaken interviews, structured interviews of individuals who recall or were involved in this harvest. And furthermore, my field and aerial photography investigations, they haven't been exhaustive. These are areas where I'm continuing to investigate. Okay, there's my timeline. So my timeline has 5 different stages of development of the mangrove stick industry. Just before my study period, mudworm had caused heavy losses, and so the growers needed to move their oysters off the mud away from the predator. Now, I view the legislation as a driver of change in the speedy uptake of mangrove stick culture. During the first stage of my timeline, the introductory statement of the 1903 Fisheries Annual Report stated that up until the present Act, and so they're referring to the 1902 Fisheries Act, there was no power to compel oyster lessees to improve their leased areas. It continued. Now, however, it's compulsory for lessees to cultivate their leased areas within 12 months of issue, and they must lay down suitable materials for the collection of spat, and failing to do this, the lessees will be liable to cancellation. So suitable material included stone, shells, shingle, tiles, or sticks. The fisheries reports over the first 2 phases of my timeline identify estuary by estuary the innovation of culture techniques and the efforts of fisheries officers to speed up the adoption of the most efficient techniques. Stone culture, as can be seen here at North Creek in the Richmond River, quickly gave way to the use of mangrove sticks. Now that was a technique that the fisheries officer in the Tweed strongly recommended in his 1909 report. Soon stone culture was openly criticised. The 1913 fisheries report describes it as a very crude method. You can see mangrove stick culture there in the Richmond River. If you've gone to Ballina and caught the ferry in the Richmond River, you've more or less gone right past this point. So improving oyster culture techniques did not just rely on the Fisheries Board working with oyster farmers. Prior to 1919, felling and removing mangroves was managed by the Forestry Department, the forestry branch of the Department of Lands. The Fisheries Board felt that forestry's management of mangroves limited the wider adoption of mangrove stick culture. The 1913 Fisheries Annual Report refers to the disabilities under which oyster lessees labour in not being able to obtain permits within a reasonable time to cut and take mangroves to cultivate their leased areas. 5 years later, the Fisheries Board, in their report, raised the matter for a 3rd time, this time noting the ruthless cutting of black mangrove, but still maintaining that the issue of permits for this operation should be one for this department instead of the forestry branch. So in 1919, management of mangroves did become the responsibility of fisheries, and subsequent annual reports record the revenue from issuing mangrove permits, and this quickly increased through the 1920s, as you can see in my graph. Yet all through this time, the Fisheries Board reports also included more and more accounts of river mangroves being overharvested. The first report occurs in 1909. A fisheries officer from the Camden Haven reported, "A motorboat has now been supplied by the lessee for the purpose of towing and collecting mangrove for catching spat. The heavy inroads made on this material has almost exhausted the home supply, and in future long distances will have to be traversed to find suitable supplies. Without the aid of motor power, this will be a slow and expensive undertaking." With hindsight, we can actually see how accurate this report was. Over the next 10 years, more and more reports were received from other estuaries. So, against this backdrop of a key resource being depleted, the 1920s was a boom period for oyster aquaculture. Foreshore length devoted to oyster aquaculture in New South Wales passed 600 miles and continued to briefly pass 700 miles. Now remember the requirement to lay down culture in those leased areas. The enormity of the industry in Port Stephens is widely reported. In 1923, one lease area in Salamander Bay had 165,000 sticks, and there were 2.25 million sticks in the North Arm alone. We heard yesterday from Michelle that one of the Aboriginal fellows working on those leased areas talked about his boss, explaining that there were battens for holding oyster sticks that would continue all the way from Port Stephens to Melbourne. And these oyster sticks, they're placed about 1 foot apart on those battened sticks. The other thing to remember these oyster sticks, they required being replaced every 3 years. The first article I can find about the shipping of oyster sticks dates from the 1st of November 1924. The record, and it records sticks being shipped. Say that, that's very hard. So it records that. From the Lower Macleay to, not surprisingly, Port Stephens. And a year later, a fisheries officer reports on over 1 million sticks being harvested in a 3-month period from the Hunter and the Hastings and being shipped to Port Stephens. The suggestion of further shipments from Macleay saw local oyster growers complain, and then that prompted the Port Stephens growers to look further afield, but not before making deputations to the minister in 1927. So the first record I have been able to find of mangrove sticks being shipped from the Richmond is December 1929. The article itself, however, refers to earlier shipments. Now, with my incomplete record and using the dates of shipments and the names of vessels to avoid duplication, I've tallied the known shipment of mangrove sticks. And so over a 10-year period, I can conservatively verify that over 3 million mangrove sticks were shipped from the Richmond River. So my field investigations have found river mangroves matching the description of those harvested, have generally 20 to 30 sticks growing in a 1 metre square. So at 30 sticks, let's overestimate here, and it makes the maths easier, per square metre, that's 3 million sticks, that's about 100,000 metres square, 10 hectares. Or if you say, consider that the river mangroves in a lot of areas are forming that fringe along the riverfront, and say that fringe is about 5 metres wide, we're looking at about 20 kilometres worth of river. Now these calculations are just for the shipped sticks in the 1930s. They don't factor in the use by local oyster farmers over the previous 30 years, nor other uses. Mangrove sticks were used to line drains, they were used as a tanning agent, and they were also used to corduroy roads. So where you had a road going through a muddy area, cut a whole lot of mangrove sticks, strengthen up that ground, and then put your road over that surface. Very useful stick. By the 1940s, the scarcity of mangrove sticks was widely evident. Their price of 12 to 14 pounds per thousand was heavily inflated on the £1 per 1,000 being paid in the 20s, and some sticks were being sourced from Queensland. Several newspaper articles state that the decline of river mangroves was having a detrimental effect on the oyster industry. And in 1949, the Fisheries Report recognised the scarcity of mangrove sticks as a contributing factor to the decline in oyster production. The oyster industry began investigating the Pilliga scrub near Coonamble in western New South Wales as a source of sticks, and ultimately a suitable alternative was found with racks of tarred hardwood sticks. So some known areas of mangrove harvest are evident in the 1942 aerial photography. So you can see these areas up here, and you can probably see some small regrown areas back through there. You can also see this area evident here. So this is an aerial photo of the Broadwater, just a small part of the Broadwater in the Richmond River. So when compared with today's image, yeah, certainly some river mangroves have grown back. For other sites, however, where earlier clearing occurred, determining the recovery or otherwise is less clear-cut. For instance, a 1936 newspaper article describes a Mr. W. Leeson's property at Pimlico where mangrove harvest was occurring. So using the parish maps, it's actually possible to be able to identify the property and then investigate using aerial photos and field investigations. And so ground truthing builds the case that in some locations anthropogenic factors really limited the recovery of river mangroves. Clearing of the dense foreshore thicket of river mangroves was an enabler of other activities. Up until the 60s, the river was still a significant transport route, and clearing of mangroves provided landholders with improved access to the river, and so many landholders maintained that open space. This was generally as easy as grazing stock on the riverbank, cattle are well known for their love of mangroves and anecdotally prefer the river mangrove. Now, even today I regularly talk with particular landowners who are suffering salistasia. You know, they're saying, oh, there are these mangroves growing where they never were growing in the past. Their past is clearly not far enough back. So the increased opportunity, there was also an increased opportunity for drainage as acting as another motivator to limit the recovery of dense thickets of mangroves. So removal of a mangrove thicket enabled some creeks to be transformed into a primary means of draining wetlands on farms. And subsequent installation of floodgates maximised the drainage but also prevented the re-establishment of mangroves. And chemical use on farms may have also limited re-establishment. There's some biological factors at play here too. Two species of mangrove dominate our wetlands in New South Wales, the grey mangrove and the river mangrove. Now while the river mangrove favours slightly less saline conditions, both mangroves occupy a relatively similar niche and are, you could say, in competition over much of their range. Now the competition starts relatively evenly as both species are viviparous, meaning that the seedlings germinate and begin to grow before detaching from the parent plant. Neither species develops a seed bank either. Work from Peter Clark in Jervis Bay informs us that from here things tend to go in favour of the grey mangrove. Grey mangrove produces more propagules per tree. The river mangrove, it suffers higher predispersal mortality of those propagules. The river mangrove propagules are smaller and they tend to sink rather than float. They're also vulnerable to predation from crabs. And this is made worse, in fact more predation from crabs than the grey mangrove. This is made worse by the fact that the river mangrove drops its propagules, 1 minute, okay, just leading to winter. I'll have to move on a little bit. So it drops its propagules just in the lead into winter. Clark formed the view that river mangroves would dominate, that grey mangroves would dominate under conditions of disturbance. So the removal of 20 kilometres minimum of river mangroves from the Richmond is a pretty healthy disturbance that would severely suppress the supply of propagules over many years. Key questions that require further investigation include, did the river mangrove coppice? Did it shoot from its stump? Anecdotally, I'm told that once the river mangrove was cut for an oyster stick, it didn't reshoot. And because the longer sticks were paid the most, harvesters probably cut their river mangroves quite close to the ground. And then that left the river mangroves without any leaves. You can see in the slide up there that one of the adaptations for the river mangrove is to exude salt through its leaves. So without that adaptation, their ability to keep going would have likely been suppressed, exhausted. To conclude, I began my talk by explaining that I protect mangrove wetlands. The policies that guide my decisions are influenced by an understanding of ecological processes and our appreciation of earlier impacts. Investigating changes in the extent of mangrove habitats using aerial photography is critical because it sets a quantifiable benchmark to about 1940. This, however, is after the harvest of river mangroves for oyster sticks. So my work here tries to capture an appreciation of that scale of the harvest. It raises many questions though. What happens in wetlands when river mangroves were being cut down and while they were growing back? Even though we don't have these answers, our management of mangrove wetlands can actually be better simply for knowing that mangrove wetlands have been so extensively disturbed in the past. With this in mind, we need to adopt an approach where mangrove wetlands are managed in a way that maximises beneficial environmental services, rather than just trying to protect sites without giving any thought to the legacy of earlier impacts, which might still be compromising their ecological value. And we probably also need to reset the baseline, where too requires considerably more investigation. Thanks very much. Now, let's see. River mangroves are this low shrub here that forms a dense thicket along the foreshore of our estuaries. Now you can see them there as the hedge in front of the grey mangroves, which are the taller shrub behind, in fact taller tree behind. There we go. So river mangroves were extensively harvested for a range of uses, particularly as sticks for oyster culture during 1900 to about 1950. Now this is only briefly mentioned in the literature, and in fact most wetland managers who I've spoken with don't really appreciate that this harvest happened, and they're certainly not across the scale of the harvest. So in my presentation today, I'm going to be discussing river mangroves. So as Jody explained, at Fisheries, I protect coastal wetlands by assessing development proposals that could have impacts on them. And so I minimise those impacts with a range of different conditions imposed on the developer. So as I'm doing my job, I often wondered just how impacted are our coastal wetlands? Through a range of assessment of reports, so using a range of reports, I've constructed a timeline of key events that shaped the harvest of these river mangrove sticks. Now I've attempted to quantify the scale of the mangrove stick harvest from the Richmond River using shipping records. And then I'll conclude my talk by outlining how the biology of river mangroves supports the case that this extensive harvest has left a legacy on our coastal wetlands. And because of this, I'm suggesting that we may need to rethink the baseline. So, how were these river mangroves used? During spring and summer, free-swimming larvae from the Sydney rock oyster, they search for a place to settle and develop into an oyster spat. So suitable materials can be set out to maximise the settlement of this spat, and this material is known as culch. During the 1900s, 4 to 6 foot lengths of river mangrove sticks in bundles of 10 to 15 quickly became the preferred method of culch. About 6 months after a heavy spat fall, the oyster farmer would take those bundles, which you can see in the top slide, the bundles of mangrove sticks, and they'd move them into more brackish waters further upstream. So the individual sticks were then staked out, forming dense rungs. About 2.5 years later, they were harvested. By this time, the bark of the river mangrove, river mangrove stick was rotting, and so hitting the side of the stick on the gunnel of your oyster punt would see the marketable oysters fall off into the punt, and then the stick was thrown away. So it was rather efficient sort of use. And so for the work I'm reporting on today, I've reviewed 65 different annual fisheries reports between 1883 and about 1960. The reports prior to 1921 were 70 plus pages or so, and they included region-specific updates. Later reports are generally less specific, only about 20 pages. I used Trove to access newspaper articles from last century using search terms oyster stick, mangrove stick,